Hello everyone, welcome to this video. In this video, we'll be solving question 11 from miscellaneous exercise on chapter 9. So here the question says a GP, it consists of an even number of terms, right? So total number of terms is even number. If the sum of all the terms, right, if you add all the terms, that is 5 times the sum of terms occupying the odd places. So suppose if we consider our GP to be A1, A2, A3 and so on, the last term I'm taking this to be A2 and Y because for every value of n this term would be placed at an even position, correct? And so here they are saying if you add all these terms, this would be equal to 5 times what? It would be equal to 5 times the sum of terms which occupy odd places. So A1 plus A3 plus A5 and so on, like this, plus A up to plus AN minus A2 n minus 1, right? So we first of all assume what they are saying. They are saying you need to find the common ratio. So we assume that its common ratio is R, right? And we will find what is this R. And we assume the A to be the first term, right? So what would be the sum of all the terms? So we are looking for S2n because our total number of terms is 2n. So S2n would be equals to the formula A R raised to power the total number of terms, that is 2n minus 1 divided by R minus 1. So let's mark this as equation 1. Now in order to find the given condition, we need to find the sum of the terms which are placed at odd places. So that means we are to find A1 plus A3 plus A5 and so on up to A2n minus 1, right? So obviously your first term is A. What is your third term? According to the formula for the general term, it is A R raised to power n minus 1. So A3 would be A R square, A5 would be A R raised to power 4 and so on. A2n minus 1 would be A R raised to power 2n minus 1 minus 1, which is R raised to power 2n minus 2, right? So when you add all these terms, the right hand side would also be added together so that you would have A R square, A R raised to power 4 and so on, all added together. You can take A common from each of the terms. So you'll be left with 1 plus R square plus R raised to power 4 and so on up to R raised to power 2n minus 2, right? Now let's mark this sum as S1. Let's call this to be S1. Now if you notice that this also forms a geometric series, right? S1 forms a geometric series where our first term is 1 and the common ratio is R square because R square divided by 1 is your common ratio, which is R square, right? So therefore, and how many terms are there in total, right? In total we have 2n terms. Now we have clearly taken the half of it because we have taken the terms which are placed at odd position, so they are total n in number, correct? So in total n terms we have, right? And then so your S1 would be equal to what? A, the first term, multiplied with your common ratio, which is R square raised to power the total number of terms minus 1 divided by the common ratio, which is R square minus 1, right? So when you solve this, you would have this as R raised to power 2n minus 1 divided by R square minus 1. Mark this as equation 2. Now using equation 2 and using equation 1, we may write the condition that is given to us, that the sum of all the terms is equals to 5 times the sum of all the odd terms. And what is the sum of odd terms? We have calculated this sum to be equal to AS1, right? So it is AS1. So you can now substitute the value of S2n using equation 1 from here, right? And moreover here, and moreover 5 would be as such, A would be as such. The sum of S1 could be written here using this equation 2. This is the sum S1, right? So writing it here, and now we have to simplify the things. So what you can do, here you see this A and A gets cancelled with each other. This term gets cancelled with the this term, right? So this R square minus 1 could be taken on the left and R minus 1 could be taken on the right, so that you would have this term. right? Now you can simplify this. You can multiply the terms together and shift it to left hand side, so that we would have r square minus 5r. Here you have minus 5, it would become plus 5 on reaching here. Plus 5 minus 1 is plus 4 is equals to 0. Now this is a quadratic equation. We can very easily solve this quadratic equation, right? We can factorize it, and you see r minus 1 and r minus 4 becomes its factor. So either r is equals to 1 or r is equals to 4. Now let's take the case when r is equals to 1. If r is equals to 1, and suppose we have 10 terms, which is an odd quantity, right? So that means we would have 1 for the each term, right? So according to the given condition, the sum of all terms, which is 1 plus 1, how many times? 10 times. It is 10. Sum of all the terms is 5 times the sum of terms which are present at odd positions. So for the odd positions, we would take the one which are present at the position 1, 3, 5, 7 and 9. So which comes out to be equal to 5. So clearly you see this 10 is not equal to 25. So this thing is not possible. Hence r is equals to 1 case is rejected. Hence we are only left with r is equals to 4. Hence r is equals to 4 is the required common ratio which we wanted to calculate here. So I hope you understood this question well. Well, that is it for this video. Thank you for watching.